And that's good news because we're going to do more of it today. So we've been looking at solving for two unknowns using two equations, right, which is a 2x2 system. Generally, the way things go, I don't know why the way things work is that you can solve for as many things as you have equations. So if I, need to solve for, I don't know, 5 unknowns, then I need 5 or more kind of pieces of information or equations or, things relating them together. We'll talk probably Thursday, hold off for this, but we'll talk a little bit about like where this kind of idea gets used a little bit. But today we're going to look at kind of the mechanics. Sorry about that. Oh, okay, good. I'm not bad at counting. I mean, I am, but that's not why you're walking up here. Today we're going to look at how we solve a 3x3 system. So 3 unknowns, X, Y, and Z, and 3 equations tying them together. The good news is that we're just going to do all the same stuff that we've been doing, only more of it. The slightly less good news is that when you increase the number of unknowns, the number of variables, if you want, we're also increasing the dimension. So these 3 equations are all linear, right? Everything's degree 1. But because there are 3 unknowns, if I try to think of them like graphically, then what that means is that instead of being a 2-dimensional thing, like a line that I can draw on the blackboard, it's the 3-dimensional equivalent of a line, which is a plane, right? So these are flat planes that live in 3-dimensional space. What that means is that graphing kind of doesn't really help us anymore, right? Because to graph, I mean, there are 3D graphers, like here is one. But you're looking at a 3-dimensional picture on a 2-dimensional screen, and it all becomes just like a little bit harder to deal with. But this is what this first example, this is what this thing looks like. There's a plane. The way you set up a 3D graph is you take the XY plane, the normal thing we normally graph in, and you cross a z-axis perpendicular, sort of coming out of it. So we have these 3 planes, and what we're looking for is still where they intersect, right? So looking at this, I see that there appears to be a point right here that they all go through at the same time. I didn't mean to make that spin that fast. I'm going to throw up, and that would be bad. There appears to be one point that they all have in common, but like I can't really figure out what it is from looking at this, right? Or at least not in a way that I feel good about. But that's what's going on in the background. Like it's still finding intersections. It's finding points that these things have in common. It's just that we've increased the dimension, and that makes the visualization part a little bit harder. Good news, though, again, is that the mechanics, how we work through solving the stuff, we don't really do anything different. We just do more of it. So that means I'm still thinking about substitution and elimination. I'm still looking for ways to combine these to, get rid of stuff and kind of simplify the system down to the point where I can find something, X is 5 or something, and then start working my way back up to find the Y and Z values that go with it. The one thing I'm going to mention before we jump into actually looking at this example is that all this stuff, I've been trying to be very intentional about kind of keeping notes about what I'm doing and trying to keep things organized and that kind of thing. That's because here we're going to be doing all the same stuff, but we're going to be doing a lot more of it, right? So it's pretty easy if we're not careful to get lost in all of the stuff and kind of lose sight of what we're trying to do. Okay, so if I'm looking at this system and thinking in terms of either looking for some kind of substitution or looking for some kind of elimination to do, what do you see? Why? What about it? Here I've got plus y plus 1y. Here I've got minus 1y minus 1y. That means if I take 2 of those and start combining them, what's going to happen to the y terms? They're gonna drop out, right? I can do this the same thing with Z, right? Plus Z, plus Z, plus Z. They're all, the same, so I can get those to drop out as well. I could do it with X, but I'd have to start multiplying in to change coefficients and stuff, right? So not really like harder, just more stuff to do. So the thing that, jumps out at me also is the Y terms there. So let's work on that then. Let's try to eliminate Y. Okay, so we're gonna do it, we're gonna take like 2 of these at a time and combine them rather than like all 3 together.
Okay.
Yeah, so I'm gonna take 2 of these at a time. So I'm gonna label them just so I can kind of keep track of what I'm doing. So I'm gonna call these, 1, 2, and 3, or A, B, and C, or whatever, just so I can again kind of keep track of what I'm doing. So if I'm trying to eliminate Y, what's one pair of those equations that we could take and combine to get rid of Y? Okay, take 1 and 2 and do what with them? Add them together. If I take 1 and 2 and add them together, what happens? Two x plus negative x, so 2x minus x. Y minus y, those drop out, and then z plus z, so 2z, is 9 plus 9.
Isn't it supposed to be plus 10? Because you're adding.
Oh. Yeah, no, I just copied it down wrong. Sorry. That should be a 1, right? That's what you're talking about?
Yes, sir.
Yeah, okay. Yeah, no, sorry, I just copied it down wrong. And that's a good point. And I promise I didn't do that on purpose. But what we're going to be doing by the time we get done working this thing, we will have done, I don't know, 50 or something, like small little things, right? Whether it's just, I made a mistake just copying the problem down from here to here, right? Let alone we're doing 1, 2, 3, 4 little arithmetics. Each one of those is a little opportunity to make some goofy little mistake that, then like throws everything else that follows after it off, right? So the math here is not difficult, but there's a lot of it going on. So just slow down a little bit, double check things, especially for the computer graded stuff, because you make some goofy little mistake there. Everything else after it's going to be, wrong then, right? And just counted as wrong, and you get the big scary red X thing. And it's really hard to find that kind of mistake when it's your own, right? When somebody else is watching you and pointing it out, that's one thing. But me trying to go figure that out myself later is going to be hard to do, right? So just, slow down enough on these. Okay, so I get this, X and Z, right? Now what?
The other equation, but you,
To do what?
well, you can either minus off the x or the z out of the other equation. You said because you add them individually.
Mm-hmm.
So if we take the new 1 and 2,
Uh-huh.
and either times or the 3 or times the 1 and 2, we can cancel out the x or the z.
Okay. So big picture, what needs to happen is we just took 2 of those equations and combined them together and got a thing that's got 2 unknowns in it, right? How do you solve for 2 unknowns? Right? And the way you do that is by getting another equation that has the same 2 things in it and solving that smaller system, right? So this is like an iterative reductive thing. You combine them, you reduce it down to 2 unknowns, but then to solve, I have to do that again, basically, right? I need to take some other combination and combine them so that I get a thing in X and Z again, and then go from there, right? In other words, I have to be considering this thing sort of as a whole, like cohesively. I have to bring all three of these equations into place somehow. I haven't used three yet, right? So take some other combination, combine them so that y drops out again. That part's important. So take either 1 and 3 or 2 and 3 and combine them so to get rid of y again.
So you have this take the equation you already did and do the other equation. And then just add-
What would you have done with that?
See, well, what I thought we were gonna do was add that to the third, but that actually makes a lot more sense.
Okay, yeah, so think about what would happen if you do that.
Yeah, we'll have another one.
Right. If you add those, you can do that if it's going to be helpful, right? If it's going to be productive. In this case, with like what's going on in the individual equations, this isn't like helping me, right? It's not going to go in the right direction because now I've just got another thing with X and Y and Z. I need to be like reducing things or eliminating things, not like adding them back in, right? So like that idea is fine. You could do that if it would, go somewhere, if it would help. So yeah, I don't mean to make it sound like, there's only like you have to do this elimination or whatever. You can do substitution. You can, whatever kinds of combinations of these things work and make sense and kind of move us in the right direction, right? What we need to be doing is reducing things down. I've taken two of these and gotten a thing that is reduced down, right? It doesn't have a Y term in it. But then to solve for X and Z, I need another thing that only has X and Z in it. So I set out to, find another one, right? That's what I'm doing here. Sometimes, and you'll see this as you like work through problems and stuff, maybe you combine things and like X and Z both drop out and you get just Y equals 5. Like that's great, right? That's a happy little accident. And then you can use that and keep going, right? So that kind of stuff happens. But the goal needs to be, how do I like reduce this down in a like productive kind of way, right? So I've got these two equations in X and Z. If you used, something other than if you use like 2 and 3, then yours might be different. But we take these two things, and what that does is gives us a smaller system, right? It gives us a 2 by 2. So X plus 2Z equals 10. And 5X plus 2Z equals 18. Yes. There you go. So I take those two new equations that I found by combining stuff, and I take those aside. They're in terms of the same two variables, so it's a 2 by 2 system, and then I solve it. So X plus 2Z equals 10, 5X plus 2Z equals 18. What do you want to do? Subtract, okay. Negative 4X is negative 8. So X is 2 then. And at this point, we should like breathe a sigh of relief because like we're over the hill now, right? Like we've got one thing. Now we're just gonna the hard part's over. We're just gonna start kind of working our way back up and finding the stuff that goes with it. So what do you want to do with x equals 2? Plug it back in where?
Top equation.
Okay, yeah, yes, this time, sorry. Yeah, right, okay, because,
And then it's easier than 5.
okay, and if I plug x in, then I can find z, and once I've got x and z, then I can go back here somewhere and find y, right? So plug it back in somewhere, but plug it back in somewhere that's gonna help, right? So take this, plug it back into one of these. If x equals 2, then the thing I've got labeled 4 becomes 2 plus 2z equals 10. So 2z is 8. So z is 4. And then back all the way up to, any of the original things and take that x and that z and plug them in to find y. Assuming that we've done everything, correctly, which is like how we always want to operate, then it doesn't matter where I plug it in, they're all going to give the same thing anyway, because we're finding the ordered triple that makes them all true. So I'm going to plug into equation 1. 2x was 2 plus y, I don't know yet, plus z is 4. So y plus 8 is 9. So y is 1. So the solution is the ordered triple x, y, z 2, 1, 4. Which again is representing a point in three-dimensional space where these three things intersect at the same time, which is why we write it as a point in the same way. Okay, questions? Okay, do you see what I mean about it just being a bunch of little things? Okay. So the things that I would, again, maybe kind of reemphasize, try to keep things organized. You don't have to do things the way I do things, of course, but try to keep things organized, like both for yourself and for, a hypothetical grader. This is a place where it's really easy, and I see this like every time I've had to grade a bunch of these or whatever. You can jump in and start like adding or subtracting, or multiply by one of them by 5 and then add them together. Do stuff like that that is like perfectly valid, but just kind of like chase your own tail around for like a page and a half of stuff and not really get anywhere. Does that make sense? Like I could take these two and add them together like we did and get x and z. And then I could go back and say, oh, well, hey, I can take these two and eliminate z if I subtract, right? And like you do that correctly, but that doesn't help because now you've got two equations, but they're different kinds of things. So they're not going to like go anywhere, right? So I've seen, stuff where somebody on an exam or whatever has done this kind of stuff, done like 4 different combinations of like correct elimination things, but then like still can't really solve the problem because they're not the same kind of thing. Like they're not compatible, right? They don't go together. So pause for a minute and just kind of make a plan about what you're going to do. And then like keep that in mind, right? If I started by eliminating y, I'm going to have to do that again so that I get a 2x2 system, so that I can reduce it down, so that I can keep solving and so on. Once you get one thing, the hard part's over and you just start kind of working back up and finding what goes with it. But getting to that first thing is kind of a lot sometimes. Okay. Okay. So, and again, I pretty much just used elimination all through this. You can do substitution as well. Like that works equally well. Kind of taking a look at the problem for a second and thinking about, what you might be able to do with it. Sometimes that's helpful. Flip over to the back real quick. a couple of these, look a little bit weird, right? But it's because there are terms that don't appear in all the equations, so it's just, like the y term is 0 there or whatever. But I've got them lined up so that, like terms are kind of in the same place. If we're a little bit, careful or strategic about how we get into this, though, that actually means that there's less work to do as long as I'm, again, kind of like planning how I go about it. So let's take, 10 minutes or something. You guys give, some of those a shot. We'll talk about, I don't know, one of them together, but try to decide, like what you want to do. What do you see that you could use as a good kind of opening move? A lot of these, there's, maybe one place where you can see kind of a first step pretty easily, but then if you do that, then that determines like what you do from that point on, right? So take a few minutes, work through some stuff, think through it on your own, and then talk to people around you, and we'll reconvene in a minute here. Okay. And 3 is negative 2x plus y plus 4z is 14. We're adding. So when I add, I get 4x plus negative 2x, negative y plus y, which is 0, which is good because that was the idea, and 7z equals 12. Okay. So eliminating y there gives me an equation that's only got x and z in it. Which means, what do we need to do next? Get another equation that's only got x and z in it. So do the same thing with something else. Eliminate y again using something else. These two, maybe? Okay, so I'm going to take the top line, I'm going to multiply by 5 to get the coefficients to match, right? So 5 times 4x minus 5 times y, 5 times 3z, 5 times negative 2. And then I'm just going to copy the second line, the second equation down. And then I've got 5y and negative 5y. So I'm going to add so that those drop out. I get 23x, 14z, and 5. So what I just learned is that 2x and 7z is 12, and 23x and 14z is 5. So now we go solve that smaller system. You could, I got 7 and 14, so I can multiply this one by 2 and subtract. That would be one way to do it. You can do a substitution. You can do whatever you want. Eliminating that's probably the most straightforward way to go. But you do that, you find x, you back up, you find z, you back up again, you find y. Okay. Getting here is kind of the tricky part, right? Because I, talking with several of you, you did, something like this, and then kind of weren't sure like where to go after that, right? The thing to keep in mind is just that whatever you did in that first step, that's going to kind of drive what you have to do after that. I got rid of y here. Well, okay, I'm going to have to get rid of y again somehow then. Right? And the second one might be a little more complicated, right? I might have to work a little bit harder to do that again. This one I kind of got easy because those lined up already. After that, well, I might have to, do a little bit more, put a little more effort into doing the same thing, but we have to do kind of the same thing again. Okay. Okay. All right. Stuff on the back. This one is 2, 2, 2, so don't see that and think that, well, that can't be right because that answer is too nice. It is. Similar sort of deal. And then the very last problem, I asked you to first set it up. So you've got you know, sort of the same thing that we started with when we started talking systems of equations. You got sort of three separate orders, three separate items and their totals. But once you just set up and then solve the system